Welcome to True Projects. In this video, we are going to explain about a project titled Leukemia Cancer Detection Using Deep Learning. Leukemia, a form of cancer impacting the body's blood-forming tissues. This disease can silently advance through all bodily organs without external cues, potentially giving rise to various other elements. Detecting the leukemia in its initial phase poses a challenge due to the time-intensive nature of current diagnostic method. To address this, the objective is to identify the early stage leukemia by employing the machine learning algorithm and analyzing the images of peripheral blood smears. This entails gathering such images, subjecting them to pre-processing, segmentation, and feature extraction, followed by classifying them using YOLO algorithms. This comprehensive approach aims to enhance the efficiency and accuracy of diagnosing the leukemia promptly. Employing the sophisticated machine learning methods, the primary objective is to early identification of leukemia in blood samples. This project involves the acquisition of peripheral blood smear images, which serve as the foundation for the subsequent classification procedure. Through a series of steps, including the pre-processing, segmentation, and the feature extraction, these images are prepared for the analysis. The pivotal phase encompasses the leveraging the YOLO algorithm for the classification task. And with the goal of pinpointing the existing of leukemic cells within the blood, the overarching aim is to furnish the diagnosis of leukemia that is not only efficient but also precise, ultimately equipping the medical professional with the crucial insight for the timely and effective patient treatment. And these are the basic requirements that are needed to build this project. The software requirements are Python IDE with version of 3.7, Anaconda with version of 3.7, Jupyter Notebook. Hardware requirements are operating system as Windows, processor of minimum Intel i3 and above, RAM of minimum 4 GB, hard disk of minimum 253 GB. And to know about the project, these are the steps we need to discuss. The first one is importing the packages. In this, we need to import the essential packages and libraries that are to establish the groundwork of leukemia cancer detection using the deep learning. And the second one is exploring the dataset. In this phase involving the examination of dataset containing the peripheral blood smear images, these images from the basis of the analysis are the pivotal in training the deep learning model. And the next step is image processing. Before delving into the model creation, the images undergo the pre-processing step to enhance the quality and prepare them for the analysis. This involves the tasks such as resizing, normalization, and the noise reduction. And the next step is loading the pre-trained model. To expedite the model training process, a pre-trained model such as YOLO V5, V8, RCNN, and SSD is loaded. These models are already optimized to detect the objects and images, making them suitable for detecting the leukemic cells. And the next one is data augmentation. Data augmentation techniques are applied to expand the dataset to improve the model generalization and the capability. This involves creating the variation of the original images through the process like rotation, flipping, and zooming. And the next step is processing the data based on a YOLO V5 model. YOLO V5 model, known by its efficiency and real-time object detection, is employed for processing the pre-processed images. The model is fine-tuned on the leukemia dataset to specifically identify the cells within the blood. And the next one is building the model. Here, several object detection models are built. The first one is YOLO V5. It stands for You Only Look Once. Version 5 is a state-of-art real-time object detection framework that excels in both accuracy and speed. It operates by dividing an image into grids and predicting the bounding box and the class probability for the objects present within each grid cell. YOLO V5 has evolved from its predecessors by introducing a more streamlined architecture and advanced techniques such as of CSP darknet as a backbone network and the use of anchor-based and anchor-free detectors. And the next one is YOLO V8. It is an advancement of YOLO architecture aiming to improve the object detection performance. It introduced the architectural changes and the optimization to enhance the accuracy and detection capability. This version incorporates the changes in the backbone network, feature fusion methods, and the refinement of the prediction mechanism. It seeks to strike a balance between the accuracy and speed, making it an attractive choice for the application like leukemia detection. And the next one is faster RCNA. It is widely used object detection architecture that employs a two-stage approach. It uses a region proposal network to propose the potential object region and then perform the object classification and the bounding box regression on these proposals. This architecture is known for its accuracy but be slightly slower compared to that of some real-time alternative. In the context of leukemia detection, faster RCNA meticulous region proposal and the refined classification process be aid in precise identification of leukemia cells and blood smear images, potentially providing the detailed insight to the medical diagnosis. And the next one is SSD. It stands for Single Shot Multi-Box Detector that predicts the object classes and the bounding boxes directly from the different layers of CNN. It excels in speed due to its single-shot nature, making it well suited for the real-time application. However, it sacrifices some accuracy compared to the two-stage method like faster CNN. In the context of the leukemia detection, SSD efficiency and speed can be advantageous, enabling the rapid assessment of blood smear images for the presence of leukemia cells. And the next one is user gives the input as image. Here we build a Flask as a web interface where the user can provide the input as an image. And here the next step is given input is pre-processed and with trained model used for detecting. When the user provides the input, the system pre-processes it and employs the pre-trained model to detect the object, that is leukemic cells. The model understands of the data, enabling it to make the accurate prediction about the presence of cancerous cell. And the next one is the segmented each object and put the bounding box. Upon detecting the object of interest, the system performs the segmentation to isolate and highlight the leukemic cell. Bounding boxes are drawn around the cell, providing a visual representation of the detected abnormalities. And the last one is final outcome is displayed. The culmination of this process results in displaying the final outcome by using the help of Flask as a web interface to display the result. And the execution of the project, we execute the project first, we need to open the code folder. And this is the code folder containing of various files within it. The sample folder containing of the images that will be used to test the performance of the model. And the static folder containing of the CSS, fonts, images, JavaScript files within it. And the template folder containing of the HTML documents, it typically include of home, index, notebook, sign-in, sign-up pages within it. And the YOLO V5 and EV8 models containing of the information and the training and validation sets within it. And the app.py file is an file that contains the information related to the front-end project. It includes the code written in Python that handle the server-side operation, such as processing the user request, interacting with the database, and generating the dynamic content that to be rendered in the HTML template. And the notebook is an IPYNB file which contains the combination of code, graph, and output all in one place. It allows the user to write and execute the code in the individual cell, making it a popular choice for the data science. And the signup.db is a file appear to be the database file used to store the user information. And for the execution of the project, first we need to copy this code folder path and then open the Anaconda prompt. Here we need to write a command that is cd space and paste this code folder path. By this it will change the current directory to the code folder path and then click on the enter button. Here we need to write a command that is python space app.py. By using this command, it will execute the Python script and perform the runtime check for any syntax errors or logical issues, and then click on the enter button. After running this app.py file, the Flask framework will host the application locally at the default address like this. We need to copy this link and paste it on any of the web browser of our choice, and I prefer to use the Google Chrome. I'm pasting this link and then click on the enter button. Here we redirect to this page containing of the information about it and the title of the project. Then click on the sign up button. Here it will redirect to the sign up page containing of some input details that need to be filled to create an account. But my account is already created, that's why I'm using the sign in button. Here it redirects to the sign in page containing of the username and password that need to be filled, and then click on the submit button. Here it redirected to this index file containing of the choose file and upload buttons. By clicking on the choose file button, here it redirected to this folder containing of various images within it. I'm selecting one and then click on the open button and then click on the upload button. Here it redirected to the result page and giving the result with a bounding box of containing the leukemia blood cells in the image. And by clicking on the home button, we redirect back to this folder file. We can re-upload any other image by clicking on the choose file button. I am selecting the another image and then click on the open button and then click on the upload button. Here it predicted the spasso width of bounding box like this. In this way we can predict the leukemia cells cancer detection by using the deep learning techniques. And in conclusion, that machine learning algorithms that be used to detect the leukemia at the early stage of the disease by analyzing the peripheral blood smear images. Researchers used the various machine learning techniques such as YOLO V5, V8 and the RCNN algorithms provided the most accurate diagnosis. We suggest that this use of machine learning and the deep learning algorithm can help the doctors in treating the patients by providing an efficient and accurate diagnosis of leukemia.
Thank you for watching video. For more projects please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.